Question number 11. Train and a carriage. So train carriage pushes the carriage. So we'll take this is train and pushes carriage. So the weight of the train is 2500 g. So mass is 2500 and carriage is weight is 1100 g. Mass is 1100 and the normal force is R1, here R2, and this is the engine. So engine create pushing force, gravity force of magnitude of 8,000 Newton, and there is a resistance force of for this one, for the engine, that they mention R, and for the carriage they have given 500 Newton, and also the acceleration also given. So that is 1.75 ms minus 2. Now the question is, show that the resistance to the motion R is 1200. So I'll mark this is thrust T and T, and F equal MA to whole system. So we will disregard this one, this forces, the internal forces. So now we can see three forces, 8,000, R and 500. So 8,000 minus R minus 500 equal the total mass, that is 2,500 plus 1,100 times A is 1.75. So this is 7,500 minus R equal, this is 2,000, 3,600 times 1.75. So R equal 7,500 minus 3,600 times 1.75. So that is going to be 7,500 minus 6,000 and 1,200 Newton. Part B. So this is not a tension. We need to find the magnitude of the compression in the shunt. So we'll consider this part only, or this part we can work out both, but this there are three forces here, 1 2 3, but here only two forces. So F equal ma to this direction. So this is have a T minus 500 times m is 1100 times acceleration is 1.75. So T equal 500 plus 100 times 1.75. So this is going to be 500 plus 1925. Total is 2425 Newton. Part C. Given the train must stop at next station, so driver reduce the produce. So the train driver want to stop in the next station. So what he did was he stopped this acceleration and he applied another force, that is 2000 Newton. It is brake. He applied the brake worth of 2000 Newton to stop to this direction, and now this acceleration is wrong. Now it's going to be decelerate, and we need to find the new thrust of this. So we'll consider if we equal ma to um, this setup again. So t minus 500 equal 1100 times a. So we don't know a. T equal 500 plus 110 1100 a. If we can find a, we know the thrust. Now this R already it is same 1200 Newton. Now we need to find a deceleration or acceleration, deceleration basically. So we'll consider whole system F equal ma to this direction. Then we have no forces on this direction. This is minus 2000 and this is minus 1200 and this is minus 500 and m, so that is 1200 plus 1100 times deceleration I will take as E1. So I'll take E1. So this is going to be 3600 E1. This has to be 2500 and it's still 3600. So this is 3700. So E1 equal 3700 divided by 3600 minus 30 over 36. Now T equal 500 110 1100 times A1. This is plus 110 minus 30 over 36. So 500 minus 1130.555. So we'll take approximately minus 1130. So this is going to be negative 630. So then T equal negative 630 Newton. It means I took T as this direction, so it has to be the other way around. So force in shunt is 630 Newton. Question number 11. Two particles P and Q. P is 2 meters, so I'll put P here. That is the other way around. 2 mg and this is Q is mg. This is P and this is tension T as usual. The both hang at the from a height from 2 meter distance from the floor. The system will release from the rest. Find the magnitude of the acceleration of the system. So if it is released, so this is heavy, so it will go down to A. It will go up A. We'll put F equal ma to particle B downward. So 2 mg minus T equal 2m times A. Then we put F equal ma to upward or particle Q. Then T minus mg equal m times A. So this is 1 and this is 2. When you add those together, 1 plus 2, T to 2 cancel out. 2 mg minus mg equal 2 ma plus ma, that is mg equal 3 ma. So m to m cancel out, g over 3 equal a. Now we need to find the next question. Find the speed p as it hits the ground. So this will come down. It will travel in 2 meters and hit. So it will start from the rest. So U equal, so we will consider particle P. Particle P. So U equals 0 ms minus 1. Acceleration is g over 3 ms minus 2. And distance is, we know, 2 meter. And we need to find the speed v. So v square equal u square plus 2as. V square u plus 2 times a is g over 3 times s is 2. So v square is 4g over 3. So v is 4g over 3 square root. So this value 3.6 ms minus 1 approximately. Now next part is we need to find the greatest heights of this one. So when it's this one hit, so this ball is somewhere here, and when it's the ground, so this distance it will go 2 meter high. So that is the ground level, 2 meter high. So then total 4 meter from the ground level. And also when it hits with this speed 3.6 down, so this particle has 3.6 speed up, and it will go up to here until the velocity is getting 0. Now we need to find this distance. So particle P, so it is move under gravity. For particle, sorry, Q, the starting initial one is 3.6 ms minus 1. The last velocity is 0 and acceleration is minus g. Then v square equal u square plus 2as. S mean v square minus u square divided by 2a. So u square is, we know that that is 4g over 3 minus u square is 0 divided by 2a. Sorry, so v square is 0, u square is 4g over 3 divided by 2 times gravitational force is minus g. So this is going to be 4g over 6g. G to G cancel out, 4 divided by 6, that is 2 over 3 meter. Then the total distance is 2 plus 2 plus, this is 2 over 3 meter. So the 2 plus 2, 4 plus, so C part C, 2, 4 plus 2 over 3 meter total. We discussed number 12 actually, this is number 12. So index is acceleration is both mass is equal, smooth pulley, same tension in the string either side of the pulley. Question number 13. So this is the setup. So it has mg downward, this is 3g downward, and they should have a tension. And so this is more heavy. This is 3g m. So m is less than 3, so this is heavy, so it should travel to this A. A also given that 3 over 7g. So we'll mark tension as T. So we'll start writing the equations. F equal ma to m. So this direction, uh, sorry, we'll put the other way around because it is going to upward and this is downward. T minus mg equal m times a is given, so this is going 3g over 7 up, 3g over 7, and that is the one equation. Then f equal ma to 3 kg, it is downward. Then 3g minus t equal 3 times 3a is 3g over 7. So this is 2. And when we add those two together, okay, from here we can find tension. So tension equal 3g from 2. T equals 3g minus, this is 3 times 3, 9g over 7. 21 minus 9g over 7. So this is going to be 12g over 7. And now we need to find m. So I can substitute or I can add. I can do both together actually. So I will add 1 plus 2. Then this is going to be 3g minus g equal this one, 3g minus mg. So this is going to be 3mg over 7 plus this is going to be 9g over 7. So 3g minus 9g over 7 equal 3 mg over 7 plus mg. So this is going to be 12g over 7 equal 10 mg over 7. So g to g cancel out, 7 to 7 to cancel out, 12 equal, so m equal 12 divided by 10, m equal 1.2 kilogram. Question number 14. So this is the setup. This is 0.8 G. So this is 0.8 times G, and the tension will take T, and the tension T. So this is a smooth pulley, so both tension is same, and this is a rough plane, and it says 0.5 G, and there is a resistance, a normal reaction. And since this plane is rough, there is a friction force that's called F. And now in the data it is given that 0.4 meter, it will travel 0.4 meter with 5 seconds, 0.5 seconds. So 0.4 meter with 0.5 seconds. So we need to find the acceleration. So basically it is starting from the rest. So it is starting from the rest. When we put u is 0, this particle, m is minus 1, and s is 0.4 or 4 over 10 meter, and t is 0.5 or half a second. And then for this particle, for 0.8 particle, s equal ut plus half a at square. When you put down, we can get 4 over 10.4 meter equals u is starting from rest, and t is half plus half a times a times half a square. So 4 over 10 is half a times 1 over 4 mean half a square 1 over 4 1 over 8 a. So this is a is 4 times 8 divided by 10, that is 4.8. So this is 32 over 10, that is 3.2 ms minus 2. And now we have two equations. We'll put to find the tension, F equal ma downward. So 0.8 G is positive, T negative is M times M is 0.8 times we found out A is 3.2. So T equals 0.8 times 9.8 minus 0.8 times 3.2. So T we will get 5.3. And now we want to find F. So F equal MA to this direction to the 0.5 mass. So it's going to be T minus F equal M 0.5 times A again 3.2. It's moving to this direction with 3.2. So F is T minus 0.5 times 3.2. So F equal T, we found out 5.3 minus 0 times 3.2. So this is going to be 3.7 Newton. This is particle B, actually this is particle B, and this is particle A. And part D is state how you, in your calculation, that you have used the information that the string is inextensible. So the assumption is the particle, both particle has same acceleration. That's the assumption. Both A and B have the same acceleration due to inextensible wire string. Question number 15. So two particles is hanging like this. So this is 0.5 G, and this is 0.4 G, and so above the ground it is 2 meter. And yes, now we need, so this is tension T T T T. So we have to write equation for P and Q. So F equal ma to upward for particle Q, then 2 forces T, and this one T minus 0.4 G equal mass is 0.4, and A we don't know. So this is A, and this is A coming down, and this is the first equation. Equation second, F equal ma for particle P. It's because since this is heavy, it is moving to this into this direction. So 0.5 G minus T equal 0.5 times E. So this is 2. Now from here we can find the tension and the acceleration. So when we add 1 plus 2, this is cancel out. 0.5 G minus 0.4 G equal 0.5 A plus 0.4 A. 0.9 A equal 0.1 G. So it means G equal 9 A. So A equal G divided by 9 ms minus 2. And now from 1, from 1, t equals 0.4g plus 0.4a. So 0.4g plus 0.4 times a equals g over 9. So this is going to be 3.6g plus 0.g over 9, that is going to be 4g over 9 Newton tension. So the acceleration is 1.09 approximately ms minus 2, and tension of this going to be 4.35 Newton approximately. This is G, gravitational acceleration. Next part is when the particle have been moving 0.2 seconds, the string breaks. It means where the particle is moving 0. Sorry, it is going the other way around. So this is the heavy side. When it is come to here, up to here. So now the particle, the position is in here somewhere. It's travel 0.2 second, and the string break, and then freely particle move freely under gravity and come back until it's hit. So this time is 0.2 seconds, so we need to find this whole total time. So then we want to calculate this time. So as I explain again, when this is moving 0.2 second, the string breaks, and then particle is moving freely, and then it will come uh, up to ground. So we need to find the time. So we can find when the string breaks, we can find the velocity. So v equal u plus at uh, to this direction. So v equal starting from rest, and the acceleration for this direction is g over 9, and times t is 0.2. So then v equals 0 point mean 2 over 10. So 2g over 90, or g over 45 ms minus 1. Now this time I can, now I need to find the time from here to here. So still we can put v equal u plus at to this direction. We know that when it is at top, when it reaches to highest, v is 0, and a is minus g, and t we need to find. So this is 0, and you already found out g equal 45, g over 45, plus a is minus g, it is moving under gravity, and t1. So then gt1 equal g over 45. So g1 to g1 cancel out. t1 equal 1 over 45. Now we need to find the journey time from here to here. So we have to use s equal ut plus half a at square. So we need for this, then we need to find no s, and u is starting 0, and a is gravitational force g, and t we need to find. So this is, we'll consider t2, that total journey. But now we need to apply this equation. We need to know s, the total height from here to here. So this distance is 2 meter, and now we want to find this distance and this distance. So then we have to consider this journey again. Um, so I'll write this is A and B. So we'll leave as it is. So AB journey. So we need to find this distance. We can put S equal ut plus half at square. So SAB equal starting from 0 times t is 2.2 half A. We know that that is G over 9. G over 9 times t square. T mean zero point 0.2. So zero point 0.2 mean 2 over 10 square. So SAB equal, so this is going to be 4 G 2 9 and this is 100. So this is going to be 2550 times 9 G over, so 450. So now we know this distance. Now we want to find AB, B to C distance. So BC distance. So we can put V square equal U square plus 2AS to BC journey. So V is 0 at top. U, we found out this one at the end of this one. So this is G over 45. G over 45. And A is minus G under acceleration. SBC. So SBC equal V square minus U square divided by 2A. So V square 0, U square mean G over 45 square divided by 2A, 2 times minus G. So then when you cancel out, we will get G over G to G cancel out. 2 times 45 square. I changed my plan little bit. Now we found out this distance 0.2 is. So then this is T1. We found out this time T1 from here to here. And the same time it will come to here again another T1. And the speed of this place is, we found out to this direction G over 45. Then when it is come down also G over 45 to downward. So instead of getting these big numbers, so we can work like this. Now we know this distance 0.2 from here to here T1. We found out, come back, found out T1. So we'll consider only this journey from here to here. We'll put AB, this is C, so this is again D, E. So consider DE journey, then we'll put so we'll put S equal UT plus half AT square to this journey. So this height is going to be, we found out this is 2, and this height AB we found out G over 450. So U, the what is the starting velocity when it's come down? So it is similar to the velocity of this one, the up velocity, because when it's go down and come back the same distance, same velocity, the opposite direction. So we are put into this direction. Because of that, U is G over 45, and this is T plus half. So this is A is minus G 9.8 T square. So when we solve this one, we will get a equation 4.9 T square minus 0.2178 T minus 2.0217 T equal 0. This has to be positive G because I am putting this one. So because of that, this value is positive and this is negative. So T equal minus 0.2178 plus or minus B square 2.2178 square minus 4 times E times C is minus 2.02178 over 2 times 4.9. Then we will get 2 answers. And there are 2 answers. One is minus 0.66 and the other one is 0.62. Then we need the total time. Total time is from here to here, total. So T1 plus T1 to plus this is 0.62. So T1 is 1 over 45 plus 1 over 45 plus 0.62. This is 2 over 45 plus 0.62. This is going to be 0.04 approximately plus 0.62. So total is going to be 0.66. Not this one. If I summarize, we'll find the further time it elapses until Q hits. So from here to here, so it will travel 0.2 second, and then it's the string break, and then it is under the gravitational acceleration, and it move the motion is under gravity, so it will move up to here and stop and then come back up to here. So for this journey I found out the um, velocity, starting velocity at this point. Put in V equal use 80 to this word, and the time as well for this journey T1, and the same time it will take come up to here back again the same height. So that is going to be again T1 and T1. Now we want to find this distance. This time I want to put S equal ut half a T square, but I don't know this distance. Then I had to put V S equal ut half a square to get this distance. And this distance we know already 2 meters, or 2 plus this distance equal U. So U is G over 45 to this direction. The same velocity is going, the magnitude of the velocity is same, only the direction is different. So then U is G over 45, and under acceleration, so this is plus G, and we have two answers. So we take 0.68 plus those two addition will make to 0.66.